Hey guys, we're going to look at naming acids and bases today. So the first thing that you guys are going to definitely need to have with you is your common ion table. For our class, that's on the back of your periodic table of elements. These are your common polyatomic ions, poly meaning they have more than one, okay? So we're going to look at some pretty simple rules for naming acids. So write this down with me as we go through it, and we're going to go over the very basic steps to them and then just practice a couple. So, okay. So the rules for naming acids, that's what we're looking at today. You're going to find your polyatomic ion name first. So that means, for example, if I gave you guys H2SO4, you're going to look for not the hydrogen part, but the polyatomic ion that's at the end of it. And you're going to look on the back here, and you're going to try to find H2SO4. So you're just going to be looking for the SO4 part. A good rule is they're always in alphabetical order, so you want to look over here in the alphabetical order part starting with S. And it just so happens I see SO4 right here. So that's sulfate, okay? So again, don't worry about the hydrogen part. Just look over here and look for sulfate. Sulfate. Normally, okay, that is normally what you guys would call it. That's what you've been taught to do so far. But now we're going to look at how you name them, especially when they are acids. Okay, you can identify it because it has the hydrogen to start with. So we're going to look there. Rule number one is you're always going to look for the ending. Find your polyatomic ion, look for the ending. The first rule is if it ends in ATE, then you are going to change that ending to IC. So ATE becomes IC plus the word acid. Okay. For example, sulfuric acid. Okay. So the one I just gave you ends in ATE. So you would switch ATE and make it sulfuric acid. Okay. The second rule is if it ends in ITE, you're going to switch that ending out for OUS plus the word acid. Okay. The third rule, IDE, so a couple of things. You're going to add the prefix hydro. You're going to add ic to the end. Instead of IDE, it's going to be ic on the end. And then you're going to add acid. Okay, so that one's going to have more parts. It's going to be ic, hydro plus ic plus acid. And we're going to look right now at a couple of examples of these things right here. And remember, every time you're going to need to go back to your periodic table to the back of it where you guys have a list of your common ions, and you're going to switch between those. Okay, so here's what we're going to do here. So first examples, let's say that we have H2SO4, the one I gave you guys at the top. So we're going to take H2SO4. We're going to look that up on the back of the periodic table. We found out that it is sulfate. We're going to take the ending part of sulfate, and we're going to switch sulfate, and it's going to become, according to the rules up here, ic, sulfic. Okay, so it's going to be sulfur, because that's the base element there. Sulfur, ic, acid. This is sulfuric acid. This one right here is a common acid. I've told you guys before, back when we were in regular class, that you guys need to know and recognize. Okay, so another example. Let's look at, if I give you guys H2SO3. Okay, this is H2SO3. So again, don't worry about the H part. Look at the SO3. Go back here to the back of your common ions, and I found SO3 right here, and it's sulfite. Okay, so this is sulfite. Okay, so according to the rules up there, you take sulfite, and it becomes OUS, acid. So we're going to take, this is going to become sulfur, and we're going to add us, sulfurous acid. Okay, that's that. Another one that you would get is H2S. So let's take H2S, and let's look over here on the back of the periodic table. And let's find S. Is S going to be on the back of the periodic table? No, it's not. Why? Everything on the back has more than one. How many is there when you have an S? 1. So all we have to do is look on the front and go, okay, this is sulfur. So these are polyatomic and the ones on the front are monoatomic. So if it's just 1 and it ends in sulfur, when you do H2S, it would be sulfide, right? Because everything on the front of the periodic table, we switch to ide, like NaCl is sodium chloride. So we're going to switch IDE. We're going to add hydro. We're going to add ic. So hydro, sulfur, add ic, hydrosulfuric acid. Okay, H2S, hydrosulfuric acid. Okay, so that's H2SO4, H2SO3, and H2S. Okay, so several examples. So a couple more examples that we could try. So if I cover those examples right there, I'll give you guys a couple of examples. My suggestion to you is that you pause it and you go back to your directions and you try this on your own. So let's try HCl, also a very common one that you guys probably can do off the top of your head, but I would pause and do that one really quick. Okay, notice that there is an imaginary 1 right there. So this is not a polyatomic ion, it's a monoatomic. So it's on the front of the periodic table. So it's going to end in ide, so this would be chloride. So it's going to be hydroic acid. So hydro, chlor, for chlorine, ic acid, hydrochloric acid. Okay, a couple more examples. What wrong pen? HNO3 and HNO2. Very similar elements there. And then the last one I want you to do is HClO4. Okay. So you've got HNO3, HNO2, HClO4. I would pause really quick, go to the back of the periodic table, look those up, and do them on your own. Let me move those up a little bit for you there. It's hard to see what you can see. There's HClO4. Okay, so based on our rules, okay, I'm going to go to the back of the periodic table. I'm going to find NO3. I'm going to find NO2. And I'm going to find ClO4. And again, we're looking for these guys on the back, your polyatomics, on the back of the periodic table. So let's go to the back and let's find NO3. And a good guess is that it starts with an N because nitrogen. So I'm going to look over here and I found NO3. Okay, NO3 is going to be nitrate. Naturally, NO2 is going to be, here's NO2, is going to be nitrite. And ClO4 starts with chlorine. So that one might be a little bit harder to find. As a good guess, I would look over here and see, do you see ClO4 anywhere? I see ClO3, I see ClO2, and I'm not finding ClO4. So maybe I need to look a little bit at some other areas and see if I can find any more C's over here. There's ClO, there's hypochlorite, that's not ClO4. So let's keep on looking. Oh, I found one. There's ClO4, okay? And I just had to look a little bit, you know, it's not going to take forever. And that's perchlorate. So I'm going to look at perchlorate. It's PERCHLORATE. Again, the most important thing here, those endings. Now that I've done that, I don't need this right here anymore. So I'm going to look for the ending of this. I'll go back to my rules. The first one ends in ATE. So I'm going to look at ATE. Okay, ATE, I'm going to switch it to ic. So I'm going to say nitric acid. Okay. The second one ends in ITE. So for ITE, I'm going to switch the ending and get rid of ITE. I'm going to make it OUS acid. So nitrous acid. And the last one is perchlorate. And that's a weird word. You guys are probably not as familiar with that. But it doesn't matter what the word is. You just look for the ending, ATE. ATE is going to be ic acid. So perchlorate acid. Okay, I just missed that. Perchloric acid, my bad. Perchloric acid. Okay. And that's it. So that's where you guys need to focus on, and that's into that.